Okay, good afternoon, everyone. So, Dr. Gosling was asked something about Java and the future of Java, and so I thought it was interesting that he said, you know, Java, who knows, but there are all these other interesting languages that are working on the Java virtual machine, such as Scala and Clojure. So it's not just me. He knows a thing or two, and so it's kind of the general belief that the development of Java is kind of where it is, and that really the Java virtual machine is this incredible unifying platform, more so than the Java language. And I think that's likely going to be true for some amount of time. And what quite possibly is going to happen, right now there's this huge patent trouble with that Sun and Oracle, when they bought Sun, have this patent portfolio that makes it impossible for a third party to come up with an independent version of the Java virtual machine. You can make modifications to the one from Oracle and you can freely redistribute it, but you cannot right now easily create your own version. But those patents fortunately have a finite life. A patent lives for 20 years max. And 20 years are over sooner than you think. And so it's entirely possible that sometime around 2015 or 2020, the last of the patents that might tie the JVM simply expires. And at that point, anyone can implement the Java virtual machine. It's probably going to have a fairly long lifetime, independent of whatever might happen or might not happen with Oracle. And it's generally difficult to come up with your own virtual machine. So people have been trying to come up with research virtual machines, and to get to the level of performance that the JVM has is just a very long and arduous effort. All right, so let's move outside the realm of the Java virtual machine for a little bit, and we're going to be looking at Ruby. And so Ruby is a programming language that was invented quite some time ago, 10, 15 years ago, by a Japanese fellow who wanted to take Smalltalk and give it a simpler syntax and make it usable for the kind of scripting tasks he had. He was working as a system administrator somewhere for it. And so he liked Smalltalk, but Smalltalk is a strange, very monolithic system. You work inside Smalltalk, and you always carry the entire environment with you, and it was just not suitable for doing the kind of scripting tasks that he wanted. So he invented Ruby, and so it's a little bit object-oriented, a little bit functional, very flexible, and no one cared for about 10 years. So it's been around. I've been reading articles about it once in a while, and the general feeling was, yeah, that's another language. And then in 2004, this fellow, David Heinemeier Hansson, built this web framework out of Ruby called Rails. And at the time, people were really struggling with the Java-based web frameworks. So people were using JSF and JSP and JSF, and it was a tedious mess to produce web applications with those technologies. And so he gained kind of instant success with that. So within months of him advertising this and getting it out, people were banging out websites with Rails. It was unbelievable. And so so Rails is really what got people interested in Ruby in a big way. And when you look at the job indexes as to why people are interested in Ruby programmers, 110% of those programmers work on Rails. So outside Rails, there is very little interest in Ruby, and very little is going on with Ruby. But Ruby, what we want to understand in the next 3 units is, what is it about Ruby? What is Ruby's secret sauce that makes it possible to come up with this incredibly popular framework? What is it that Hansson saw in Ruby that really other people had not seen before that made it possible for him to do this? So first of all, why do people love Rails? The first thing is that if you do anything with a Java framework, then you have to specify everything and many things in XML files that are outside the actual code that you're writing. And if you make the slightest mistake, if you misspell something in one of the XML files, then your application will compile, it will deploy, and it will fail in some way or other when you test it. And the cycle of building, deploying, and getting to the point of failure can often be several minutes. And so it's extremely unpleasant to develop in these things. And to add insult to injury, the error message is usually a part of what's called the stack trace from hell. The application server will show up a gigantic stack trace, literally thousands of lines long, and somewhere around line 300 to 700 is an indication of what it is that went wrong. So you have a really nasty development environment. So, and what Hansen said is, when he looked at most of these configurations, most of the configuration was stupid. They were that you could specify where this directory was, where that directory was, even though you could just make conventions. They will always use the same directory, and it would not change expressibility at all. So part of it was just common sense to say, let's cut out unnecessary convention. The other thing that it would not have been possible with Java was the don't repeat yourself principle. Java is full of don't repeat yourself. Even basic Java, you have to say hash table string comma integer foo equals new hash table string comma integer. There, I've just repeated myself. And when you do the kind of enterprise programming, there's tons of stuff that you have to say over and over in different places. And in Ruby, as we'll see, you can eliminate a lot of that stuff. And then the third magic sauce is every Java application suffers from this problem that you have your data stored in a relational database, you have your web pages somehow, and you have to transport between the two. And it's never fun, it's never easy. And so he did this thing where through the power of Ruby, and we'll get a glimpse at least on how that is done, where one can look at the database, where Ruby looks at the database, and it automatically generates classes out of the database. And then you use the classes, and the storing into the database and the reading from the database is trivial. It's completely free. Nowadays in Java, one can do similar things with one of the Java OR mappers, but it's admittedly very, very smooth how it works in Ruby. And finally, it turns out that because Ruby is so malleable, that one can take some of the build systems and make them into Ruby-based build systems. So in Java, we have AND, but AND is not exactly walk in the park, and it's difficult to extend and stuff. So they re-implemented something like that in Ruby called Rake, and it's written in Ruby, and it's very flexible, and it's nice. So people have this thing that works very smoothly, lets you bang out these prototype sites very quickly, and so it became really very, very successful. The only thing that's been holding it back were kind of two things. Number one is that Ruby makes it really easy to come up with, Rails makes it really easy to come up with a website that does the basic things where you can like add users, look at tables and stuff, but it doesn't necessarily make it any easier to make a website where you can sell stuff or do the kinds of stuff that people actually need to do. And so you get going really quickly, but to get to a polished end product, that advantage gets lost pretty quickly. And so the advantage is they're more for prototyping than for big developments. And the other thing is it performs terribly. That Ruby has its own virtual machine. That virtual machine was written by the same fellow who designed the Ruby language. And designing a language and building a well-performing virtual machine is probably more than one can expect a single human being to ever produce. So that virtual machine is just not very good. Some people run Ruby code then on the Java virtual machine, and that's a solution. And quite a few people take the Ruby code and then translate it into a more conventional language. For example, Twitter, which was one of the poster childs for Ruby. They started out as a Ruby application that quickly failed to scale, and now Twitter uses Scala for making its backend more scalable. But still, what's very interesting about Ruby and why we care is that it has this super flexibility that you just have to see to believe. So we're going to have the fastest crash course into Ruby ever. I did this last semester with my students in Vietnam, and they were complaining to the Vietnamese professor and say, why is it that we've gone through chapters 1 and 2 and then 24, 25, and 26 in the Ruby manual, whatever the chapter numbers were. So we're going to skip all of the stuff in the middle and get right into the hard part, because it's not my motive to make you into competent Ruby programmers. I couldn't care less about that. You could learn that yourself in a few weeks if that's what you needed to do. What I want to get to the interesting part where Ruby can do something that other languages can't do. So we will try not to cover anything that other languages can do, or just the absolute minimum that we need to be dangerous. All right, so here goes in rapid speed. Number one, Ruby is dynamically typed. So just like JavaScript, when you have a variable, notice there's no type declarations, it's just X. When you declare it for the first time, then it comes to life. And I initialize it with integer 1 here, and later I can override it with a string 1, and that's just fine. No types associated with the variable. It is still a strongly typed language, so you can't ever do, everything knows what one can apply to it. So let's look at this particular method, quack here. Quack prints x plus x plus x. We don't know what the type of x is. And how this method operates really depends on what we feed to it. When I call quack on the string q, then it prints q, q, q. Because in this case, plus means concatenation, and it concatenates them. When I do quack of 2, then it computes 2 plus 2 plus 2, or 6. When I do quack of true, then there is no plus on booleans, and then I get some runtime error. I get a runtime error. There's no way to diagnose at compile time that this might be wrong. So every kind of type error that I get is going to be a runtime error. Blocks. So as you've seen in Scala when we've done this higher order code stuff, is what makes a functional language powerful is you can give a function another function. You can give it a piece of functionality and say, do this 10 times, do this later, do these two things one after another, whatever. And so that's something that you can also do in Ruby in a kind of similar way. So here we have a collection 1, 2, 3. And that's just an array in Ruby syntax separated by commas. Dot each is like for each in Scala. And afterwards, I give the function that I want to apply. The function notation here is it's a block. It's enclosed in parentheses. These vertical bars here are holdovers from Smalltalk. They contain the parameter list. In this case, I have a single parameter a. And then here, I just wanted to print 2 times a followed by space. And since I'm applying this to each of the elements, then I get print 2, 4, 6. So this is exactly the same thing as for each in Scala. And so when one looks at this, one says, oh, this thing is a closure. And for our purposes, that is a good that's a good model. You should kind of think of this thing as an anonymous function. Now, the purists, and you can read through them when you click on this link here, will point out that there are niggly little things why this is not a closure. And the reason why it's not a closure is that ultimately that the fellow who designed this was not someone with any actual training in language design, but he was a system administrator who kind of cobbled together a bunch of features that seemed to look smart. And that's what you get. But it's good enough. If they were to refactor Ruby, they could actually turn it into a sensible language. Now, one of the weird things about these blocks, and again it shows kind of amateurish language design, is that if you want to do this in Scala, the way you pass a block to a function is you tell the function that it has a parameter that is another function. In Ruby, on the other hand, every function gets one bonus argument, and that is a block, whether or not it wants it. If the block is not supplied, then that bonus argument is nil. If the block is supplied, then you can call it in the function. What if you want to have a function that takes 2 function parameters? You're hosed. You can't do it. So because Ruby does not explicitly recognize that a block is a data type, it's somewhat limited in that. So it's kind of a hacky feature, unfortunately, but that's the way that it is. Yeah. All right. So one block can be passed, and it's anonymous. And if you want to use it, you have to use the yield keyword. So let's look at a particular example here. Here I have a function filter. What's the type of A? Oh, I have no idea what it is. We have to find out from usage. It's duck typing. So A is apparently something where it makes sense to say for I in A. It's some kind of a collection. We're starting out with the result that's empty at first, and then for each I, we call the function that is passed. You don't see it, right? It's not an explicit parameter. It's this implicit parameter. And we call the function, and if it returns true, this thing apparently returns a Boolean, then we push the result onto R, which means we append it to R. So this is not functional. This is a mutation of R. And then in the end, we return the results. So over here I have an example. I take a bunch of numbers, and then I filter it. Notice here you see the explicit block, even though in the declaration here, it was not there. And then this returns a list of the. So it's simple enough, except for this kind of hack with that a block is implicitly passed. So then you have a similar thing that you've seen in Scala, that you can omit a bunch of stuff. So it's optional. The braces are optional. If you don't like the braces for whatever reason, you have to use the keyword in instead, and that seems a fair trade. I don't think I would be doing that, but you might see some of that somewhere else. The parentheses in the function call are optional. And what if you have more than one argument? Then you can do something that's more radical than in Scala. You can still omit the parentheses, but you do have to put the commas. Now, if you think about it, why didn't the Scala people do this? Because what if you want to, let me call it AVG to be brief. What if you want to call this? Well, clearly omitting all of them is going to be ambiguous, right? And so this again, you kind of wonder whether this is such a great feature, but apparently, what they say, if it works out great, if not, we put in extra parentheses. Name the default arguments. I don't know if we've covered this in Scala, maybe not, but Scala has a similar feature where when you have a function, you can give names to the parameters, and so in this case here the name would be size, in this case the name would be style, and then you can give default names so that default value, so if you omit it, then it gets that default value. So this particular function print, I could call it by saying print hello, weight to be, say, regular. And then it would print hello, not invoke what was the default. So I've overridden the default, but all the other ones take the default. This is a nifty feature when you have long parameter lists. The way it's done in Ruby is a little bit different than it's done in Scala. In Scala, these are regular parameters. But in Ruby, it gathers everything that has these arrows and puts it into a hash map. That's the last parameter of the method. So then the method has the labor of iterating through this hash map to find out whether these things are in there or not. Notice the colons in front. They turn colon face or colon weight are almost the same thing as oh yeah, I have it with size. So colon size and quote size are almost the same thing, except that it is possible in Ruby that if you use the coded string size twice, that they're located in different locations in memory, and colon size is always located in a single location in memory. These things are called atoms in Lisp. You might have seen them there. They're called symbols in Ruby. Scala has a similar feature where I believe you say quote size. I think because I so rarely use them. But there is a feature like that in Scala. In Lisp, it's definitely code size, and you just get used to putting these colons whenever you want to have a string that's identifiable as itself. Classes. That's probably the biggest difference between any language that you've seen before. So you have a typical class. This is a tree class where a tree has a named node and then it has some children. So this is an n-ary tree. So in the node, in the root node, I can put some string or something. It doesn't have to be string. And then I have a list of children that are also trees. So I'm having an initialize method here. It takes the name, and then it takes, this is a way of doing variable arguments. So this way you can call it, do I have a call? Yes. So I say, I call the constructor. The way you call the constructor is you give the name of the class and then .new. That's actually entirely reasonable because you can think of the class as having a method called new that does construction. It's a class method, like a static method. So what do we give it? We're giving it the here there's the string hi, and then we're going to give it a list of children, and so we have these two children here. So out of that we get a tree with 3 nodes. Notice the default parameter here. So if I don't pass anything in here, then I get an empty list, and so these ones have no children. Over here, these guys here, @name and @children, are the instance variables. Instance variables, I don't know if by convention or by language rule, always start with an @. So this thing has 2 instance variables, and this declaration here, or accessor, it's kind of a meta method. It is a method that generates instance variables. It generates an instance variable for every string that you give it. So or accessor, then some missing parentheses. Let me fill them in so that you can see them better, except no any paint anymore. Wrote a script that kills that service and restarts it. All right. So here are the parentheses. So it takes a list of strings, and then it injects an instance field into the class for every one of these strings. Now this is a very, very bizarre way of making a class from the point of view of a Java program. These classes are totally dynamic. As this code here executes, so when the tree class is processed, all of the code inside here executes. And as it executes, it modifies the declaration of the class. So at this point, class tree is a class that's naked, has no instance fields. After this line executes, this class has gained 2 instance fields. They get injected as the class declaration is processed. So now it has 2 instance fields. And now it gains also 2 methods that have also now become injected as methods of the class. The first method here has 2 parameters, and it sets the instance fields to the parameter. The second method here, this is a visit, and so I want to have a tree visitation function. So if you just remember how tree visitation goes, you have some n-ary tree, and I'll want to make let's say a depth first visit. I visit the root, and then I recursively visit each of the children. So a visit obviously is something that takes a function. It applies the function to the root element, and then I keep calling that function again. Now, in the previous slide, you saw how every function, including visit, gets an implicit argument that is a block, and it can call the block with yield. Now, a couple of versions of Ruby later, this guy Max, who invented it, realized that it's kind of troublesome that sometimes you want to take that function, which you can invoke with yield, you want to pass it on to another function. That's what we want to do here. We want to recursively pass on visit to the next one. And he couldn't do it because it was an anonymous thing. And I'm going to pass something that has no name. And then I said, okay, well, we'll invent some more syntax for that. And if you have a parameter that starts with an ampersand, then, and that parameter is the last parameter, and it's a Tuesday, then that means it captures the block. The reason I say and it's a Tuesday is there's some other rules that also apply for the last parameter to do some other clever hack. And now I don't remember which one wins out in which particular situation. That's always the problem when, and even Scala suffers from that syndrome that when you try to do too many clever things, at some point they step on each other's feet. But here, it works tolerably in this situation. I can capture the block. Now, when I want to call the block, can I call yield? No, because it's no longer that anonymous thing. So now there is a bit of other syntax. Now I have to call the block like this. So I have to call block.call. That's kind of the analog of doing yield and the other syntax. And I have to pass it. The implicit self is like this. Self is just, in Smalltalk it's called self, and so they call it self. That's just syntax. So, so it's just a little bit weird that I now have a different syntax for the implicit. And then over here I invoke a function on the children, namely that I want the children to be visited by that block. So now I have a recursive visit. Now, what's remarkable about this is this very dynamic nature of classes. That classes kind of build themselves up. Now, even more. Yeah?
So in the previous slide, when we call t.visit,
yes?
that would print the name of the function, basically the puts.
Oh, let's figure out what this does in slow motion. So here we're calling visit with a function that prints, that it takes as a parameter an n, and as we can kind of see from the usage, that n must be a node. It's a tree, actually. It's one of these things. Because it prints the name that's stored in there. So now let's do that on this particular t. So I'm calling it, this thing that's bound to block. The block calls itself, so that means this n becomes t. And it prints t.name, which is cut. Then it goes on, and for each of the children, there are two children here, it calls, so for the first child, it calls c.visit in the same block. So it calls itself again, and at that point it's going to print self. So remarkably, when you have an existing class, such as the class object, just like in all these other languages, object is the cosmic root class, everything extends object, but object is kind of malleable. I can add a method to object. For example, the quack method, if I so choose. So here I'm adding a quack method that prints self plus self plus self. Now, all objects in the universe have acquired a new method, and I can call 2.quack. 2 is an instance of number or something that's a subclass of object, just like in Scala, numbers are objects. And so 2 out of sudden knows how to quack, and it'll answer 6. How about Q? Yeah, the string knows how to quack, and it'll just print itself 3 times. Now, what if I take something else? Whenever you have an object, you can get its class object by saying name the object dot class. That is an object of class, just like in Java. And at this point, it's going to say this particular object. It's an object of type fixnum.class. So this thing here, this 2.class, this mysterious thing, whatever that is, it says it can't quack because it doesn't know how to do plus. There's no addition on these objects. And that's just what happens. It has the quack method, but when you run the quack method, you get a runtime error. But so it's remarkable that if you have a class that's lacking a method, You don't have to petition the Oracle Corporation. You simply add it. And that can be very powerful and can be very flexible. Obviously, if two people have the same bright idea to add a quack method, then they're going to start stepping onto each other's feet. So it's probably not a technique that's geared for programs that are maintained by many different people. This is called open classes. So there you have it, Ruby in a nutshell. And so I want you to do a few things with it. And so at first, I want you to implement good old map. And it's the same old map that you've seen in Scala in the homework. It takes a function, takes a list, and it should return the list of values. And it's easy enough, you just take tokens. Then just so that you can get some practice with optional parameters, because those are heavily used in Rails, and we're going to be seeing that on Tuesday. I want you to just add a completely bogus optional parameter here, the descending parameter that just returns the things in reverse order. Now, how are you going to know how to do that? So I have to show you just a little bit. Huh? I didn't do my homework. Ruby. Oh, it should be IRB. I didn't know I have to install it. There we go. All right, I'll go away. So when I want to know what you can do to an object, you can ask it, what methods do you support? And you get back a list of methods. So if I want to know what the number 1 can do, I just ask it, and here I get a complete list of everything that I can do to the number 1. So I can ask it, is it even? And most of them kind of do the obvious thing. So if you have an array, you may want to know what can you do with it. And here you get them all. Now, you don't get them in alphabetical order, unfortunately. In what order do you get them? Why is there this crazy order? The order in which Matt thought of them. No. I mean, it's implemented as a hash map. So they're just the keys in the hash map, and they're just visited in the order that the hash map has them. So just by pretty random by hash code. But here you call sort on it, and then you get them in sorted order. Okay, so there is a, and I'm telling you that for a reason, but I'm not telling you the reason. All right, so that optional one, and then I still want you to do something with the tree and do a bit of where you need to make a class, and then I ask you how you can modify an existing class. So it should be a pretty harmless lab. Let's just get going with it, and then in about 35 minutes or so, we'll quickly go over it.